So we have this problem here. Sketch and find the area of the region enclosed by the curves given below. So we have y equals 2 cos x and y equals 2 minus 4x over pi. So first, let's just sketch the curves. We're going to have our vertical and horizontal axes. Hopefully we can make these a little straighter. So let's have our horizontal axis be x and our vertical axis be y. And right now we're just going to draw cos x, or rather 2 cos x. And this is going to be a sinusoidal function. It's going to be something like this, and it's going to continue waving up and down. We know that this value is 2 right here, y equals 2. And right now we'll specify this as pi over 2. We know that this is pi, and so on. Now let's sketch the curve of y equals 2 minus 4x over pi. So we know that this is a line because y is just a function of some constant times x plus another constant. So this is going to be a line. So let's start by finding the x and y intercepts. So let's find the y-intercept. So this is when x equals 0. So if we set x equal to 0, then y equals 2 minus 4 times 0 over pi. So y is just 2 when x equals 0. So we know that we have one point of this line be y equals 2 and x equals 0. Well, that's pretty convenient because this is also where y equals 2 for cos x when x is 0. So now we have the y-intercept. Now let's try to find the x-intercept. So the x-intercept is when y equals 0. So we set this entire function equal to 0. So we set 2 minus 4x over pi equal to 0. So now if we solve, we move this to the other side, we get 4x over pi equals 2. Whoops, I meant to write pi there. So this is going to be 4x over pi equal to 2. And we know x is equal to 2 over 4 times pi, which is just pi over 2. So if we draw that on our graph, then we have this point. So what we can do now is connect the dots. So we'll draw a straight line going through this, these 2 points on the curve. Let me see if I can make this line straighter. Something like this. And this line continues on until infinity. And we have these 2 regions bound by this line and this curve. Now, we can see that these 2 regions, they look relatively symmetrical, even though my drawing is still kind of sketchy. But if you can look at this, you know that cos x is sort of symmetrical around the y-axis. And we can see that if you take the area of this region over here and multiply it by 2, you get the area bound by this line and this cos function. So instead of integrating this area and adding the integral of this area, what we can do is we can just find this area over here and multiply it by 2. So let's do that. Let's set up our integral. So we have the area of the region bound by the curves equals 2 times the area of this. So we have 2 times the definite integral from 0 to pi over 2. And our top function here is y equals 2 cos x. So since that is on the top, we're going to put that over here. And the function on the bottom is this line, which has the equation y equals 2 minus 4x over pi. So we'll just subtract that from our top function. And we are integrating with respect to x. So right now, we're going to try to solve this integral. So we're going to first anti-differentiate. So we're going to see what function has a derivative that is equal to this. Now, we're able to find the area underneath the curve by anti-differentiation because of the fundamental theorem of calculus. So first, what is the antiderivative of 2 cos x? Well, it is 2 sine x, because if you take the derivative of 2 sine x, you get 2 cos x. What is the derivative of negative 2? Well, that's just negative 2x, or the antiderivative of negative 2 is negative 2x. And the antiderivative of plus 4x over pi is just plus 1/2 of 4 over pi times x squared. So if you take the derivative of this thing right over here, you're going to get this thing inside the integral. Now we're going to evaluate this from pi over 2 to 0. So right now, what we're going to do is we're going to plug in pi over 2 into all of these, and then subtract the results when we get pi equals 0, or x equals 0, into this. So if we continue, we get 2 times sine of pi over 2. So 2 times sine of pi over 2, which is just 1, minus 2 times pi over 2, plus, and we can simplify this to 2 over pi, and then pi over 2 squared. And if we plug in 0 for all of these, we get minus 0, minus 0, minus 0. So those do not matter. We'll just put in a minus 0 there. So if we simplify this, we get 2 times 2 minus pi plus pi over 2. And if we simplify this further, we get 4 minus pi. And this is our final answer.